Today I'm going to be talking about using transformations of quadratic functions. Now first off, we need to look at the quadratic function. F of x equals a times the quantity x minus h squared plus k. Now this is what we call vertex form. And in vertex form, we can find the vertex by taking h comma k, and that's our vertex of our parabola. Okay, now let's remind ourselves of which parts of this function give us what types of transformations. Now the a right here gives us a reflection in the x-axis, and it also gives us a vertical stretch and shrink. The next one is kind of it is the coefficient of the x inside of the parentheses. That gives us a reflection in the y-axis and a horizontal stretch or shrink. Okay. Our next one is inside of here, this h. That gives us a horizontal translation. And our very last piece, the k, gives us our vertical translation. It's kind of a reminder from chapter 1 of what parts of this function give us what kind of transformation. So let's practice graphing these transformations. So it says describe the transformation of f of x equals x squared represented by g. And then you're going to graph the function. Well, we have the g of x equals x squared plus 1. So this is a translation . 1 unit up, okay? And then we are going to graph the parent function, f of x equals x squared. And you should know this pattern by now. We graph at 0, 0, 1, 1, then 2, 4. That should be a really easy one for you to graph really quick, the parent function of a quadratic, which gives us a parabola. Now, instead of using a table of values before, we actually can use this translation to graph a lot faster. Since we're just translating this function up by 1 unit, all we have to do is regraph our points up by 1 unit. So we're just going to go up 1 unit. And then regraph this function. And that is a real quick and easy way to graph that parabola by taking your parent function and then moving it according to the transformation. Our next one is the g of x equals x minus 9 squared plus 5. So this is a translation again. 9 units to the right, and 5 units up. So let's graph our parent function. 0, 0, 1, 1, 2, 4. And now all we have to do is move this over 9 units to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 5 units up. 1, 2, 3, 4, 5. Now I've ran out of graph, that's okay. But from this vertex, we actually can graph the parent function pattern from this vertex. So I can go over 1, up 1, and over 1, up 1 on either side because we didn't have any stretches or shrinks, so it's going to be the same size as the original. And then I can go over 2, up 4, and the same for over here. And we did not have to use a table of values for that. We just used our original parent function and just did our translation. Okay. Now, our last one for graphing, this is going to be a reflection in the x-axis and a horizontal shrink by a factor of 1/2. Now remember, when we have a horizontal shrink and stretch, we have to take the reciprocal, and the reciprocal of 2 is 1/2. And then from that factor of 1/2, we determine if it's a shrink or a stretch. And that's why I said a horizontal shrink, because the factor is of 1/2. Okay, now we're going to graph our parent function. And now shrinks and stretches are a little bit more difficult to do by just moving it. So you can do a quick table of values if you prefer. And I'm just going to use 0, 1, and 2. I am going to run out of room. That's okay. Okay, so just a quick table of values, and now we're going to graph this. Now our vertex did not change because we didn't translate it. We just reflected it and shrunk this. So we're going to start at 0, 0, then at 1, -4, and that is a reflection that we're seeing, and then 2, -16, which is way down there. Graph that out, and now we have a reflection and a horizontal shrink of 1/2, and we've got the parent function and the new function, the g of x. Okay, next up we're going to just describe by looking at the equation, and then we're going to identify the vertex. So we're just going to look at this, and the first thing I see is that there is a reflection in the x-axis, a vertical stretch by a factor of 4, and there is a translation, 1 unit left and 5 units down. Okay, and then our vertex for this is a -1, -5, because if you remember in vertex form, the original vertex form is x minus h, so that means we have to take the opposite to get positive hk. So it's a -1, -5 for a vertex for that. And you always can graph it and double check to see if you're right on your graphing calculator to see if that's where the vertex is. Now our next one, this is going to be a vertical shrink by a factor of 1/2, and a translation, 1 unit right. And for this one, our vertex is 1, 0. Since we don't have anything being added or subtracted at the end of the function, our y value is going to be 0. So it's 1, 0. Now our next one is a little bit trickier. We go from an original function to a new function, and we're going to write a rule. So it says write a rule for g described by the transformations of the graph of f. Then identify the vertex. Okay, so we're going to take what they've given us, the f of x, and a rule is just another name for an equation. And we're going to do this step by step, one at a time. Because if we don't do it step by step and we throw everything all together, it's not going to work. So we're going to take the f of x equals x squared, and the first thing we're going to do is we're going to apply a vertical shrink by a factor of 1/3. So we're going to write the g of x equals 1/3 times x squared. That's the first thing we're going to do. Okay, and that's your vertical shrink. The next thing is we're going to apply a reflection in the y-axis. So our next step is the g of x equals 1/3 times negative x squared. Now, we can simplify this because a negative number that's squared is positive. So we can rewrite this as the g of x equals 1/3 x squared, because the negative x squared is positive x squared. Now the very last piece is a translation of 3 units to the right. So our last one is going to be the g of x equals 1/3 x minus 3 squared. And that is our final rule for those transformations. And then our vertex is going to be at 3, 0. All right. Now the next one, our original function is the f of x equals x plus 6 squared plus 3. And so we're going to apply a horizontal shrink by a factor of half first. So we're going to do the g of x equals 2x plus 6 squared plus 3. So that's the first thing that we're going to do. And then we're going to apply a translation of 1 unit down. So all we have to do is subtract by 1 at the end of the function. So we have the g of x equals 2x plus 6 squared plus 2. Now the very last one is always really tricky because it's a reflection in the x-axis. And when we have a reflection in the x-axis, we have to multiply the entire function by a negative. So we have to distribute that negative out. So this is going to be the g of x equals a negative 2x plus 6 squared minus 2. So be really careful to distribute that out to both terms. And that's our final rule. Now we have to be really careful in finding the vertex for this one, because in vertex form, the expression inside the parentheses has to have, the x has to have a coefficient of 1. So to do that, I'm just going to do this off to the side. To have a coefficient of 1, we have to divide by 2, and we get x plus 3 as our leading coefficient as 1. So now we can properly write our vertex as a negative 3, negative 2. And that is our final answer for that one.